Now the locomotive has a stroke Messiaen of 1 meter. The piston moves with simple harmonic motion with an angular frequency of 200 rad per minute. What is the maximum speed? So from this we can make it given omega is equal to 200. Amplitude is 1 stroke, so 1 amplitude will be half stroke. Formula we are using V is equal to omega into amplitude. In solution we can sub 200 meter half linear.
Hi, I'm Michelle and I will be explaining question 14.11 of the chapter Waves. The transverse displacement of a wire which is clamped at both ends is described as y of x comma t is equals to 0.06 sine 2 pi by 3x cos 120 pi t. The mass of the wire is 6 into 10 to the power minus 2 kg and its length is 3 meters. Provide answers to the following questions. Number 1. Is the function describing a stationary wave or a traveling wave? Number 2. Interpret the wave as a superposition of two waves traveling in opposite directions. Find the speed, wavelength, and frequency of each wave. Number 3. Conclude the tension of the wire. X and Y are in meters and T is in seconds. We will start with the first subdivision. Is the function describing a stationary wave or a traveling wave? We know that standing waves are also known as stationary waves and are represented by y of x comma t is equal to 2a sine kx cos omega t. The given wave is represented as y of x comma t is equals to 0.06 sine 2 pi by 3 x cos 120 pi t. Thus, it is a standing wave, as you can notice the similarities between these two functions. Here, 2a is 0.06, k is equals to 2 pi by 3, and omega is equals to 120 pi. Moving on to the second subdivision. Interpret the wave as a superposition of two waves traveling in opposite directions. Find the speed, wavelength, and frequency of each wave. We know that when the wave is traveling in positive x direction, y1 equals a sine omega t minus kx, and when the wave is traveling in negative x direction, y2 equals a sine omega t plus kx. When we superposition these two waves, we get y equals y1 plus y2. Substituting the values of y1 and y2, we get a sine omega t minus kx minus a sine omega t plus kx. We use the trigonometric formulas. Sin x plus y equals sin x cos y plus sin y cos x, and sin x minus y equals sin x cos y minus sin y cos x. Using these formulas, we can expand these two terms and we get a sin omega t cos kx minus a sin kx cos omega t minus a sin omega t cos kx minus a sin kx cos omega t. These two terms will get cancelled and we will be left with minus 2a sine kx cos omega t. Substituting the values, we get minus 2a sine 2 pi by lambda x cos 2 pi velocity t. Given y of x comma t equals 0.06 sine 2 pi by 3x cos 120 pi t. Comparing equations 1 and 2, we get 2 pi by lambda equals 2 pi by 3. Thus, lambda equals 3 meters. Also, 2 pi v by lambda equals 120 pi. Thus, velocity equals to 180 meters per second. And frequency equals to velocity divided by lambda equals 180 by 3, which is equal to 60 hertz. Moving on to the last subdivision of the question, it is asking us to find the tension of the wire, where x and y are in meters and t is in seconds. Given that V equals to 180 meters per second and mass of the string is 6 into 10 to the power minus 2 kg, length of the string is 3 meters, mass per unit length of the string equals m by L is equals to 6 into 10 to the power minus 2 divided by 3, which is equal to 2 into 10 to the power minus 2 kg per meter. Tension equals to V square by mu is equals to 180 square into 2 into 10 to the power minus 2, which gives us the tension that is equal to 648 newtons.